A manufacturing company has a number of machines which produce widgets. One machine produces 2.5 times 10 to the power 6 widgets in a day. Two other machines each produce 3.7 times 10 to the power 6 widgets in a day. And one super machine produces 1.2 times 10 to the power 7 widgets in a day. Part 1. Calculate the number of widgets produced by the company in a day. Part 2. If 4% of the widgets fail a quality test, calculate the number of good widgets produced by the company in a 5-day week. So, Part 1. Calculate the number of widgets produced by the company in a day. So in one day, the number of widgets is going to be 2.5 times 10 to the power 6, which we got from up here, plus 2 times 3.7 times 10 to the power 6, which we got here because there was two machines producing that number, plus 1.2 times 10 to the power 7, which is the number produced by the super machine. Now, since we are adding three different scientific notation form numbers, we need to have the powers of 10 to be matching. We have 10 to the power 6, 10 to the power 6, and 10 to the power 7. So I'm going to make them all power of 7. I could have made them all to the power 6 if I wanted to. But before I actually do that, I'm going to have to multiply out the 2 by the 3.7 times 10 to the power 6. 2 times 3.7 is going to give me 7.4, and this stays as 2 to the power 6. It doesn't become 2 to the power 12 or anything like that, it just stays the same. Think of it like if it was 2 multiplied by 3.7x or 3.7y, something like that. It would still stay as x or it would still stay as y. Think of it like it's a variable. So 2 times 3.7 is going to give us 7.4, and that's still times 10 to the power 6. So now I can change the 10 to the power 6 to 10 to the power 7. So if this 6 becomes 7, I'm making the power bigger. And if the power gets bigger, the decimal point moves to the left. So this 2.5 becomes 0.25. And the 10.6 becomes 10 to the power 7. I'm going to do the same over here. This decimal point will move to the left. The 7.4 will become 0.74, and the 10 to the power 6 will become 10 to the power 7. I don't have to do anything to this because it was already 10 to the power of 7. Now I'm going to take out the highest common factor, which is the 10 to the power 7, and I'm just going to add the numbers that are left over. So I've got 0.25 plus 0.74 plus 1.2, which is going to give me 2.19. So I bring the 2.19 down here, and that's times 10 to the power 7. Now, we were asked to calculate the number of widgets produced by the company in a day, so we want the actual number of widgets, not in scientific notation. So if we have 2.9 times 10 to the power 7, we need to move that decimal point 7 places to the right. So the decimal point was originally here, just after the 2. So I move it 1, 2, 3, 4, 5, 6, 7 places to the right. And I end up with 21,900,000 widgets. Next part of my question said, if 4% of the widgets fail a quality test, calculate the number of good widgets produced by the company in a 5-day week. So another way of saying the number of good widgets is by saying the number of widgets who passed the quality test. So if 4% of the widgets fail, then 100% take away 4% will leave us with 96%, and that would be the number of widgets that pass the quality test. So that would be the number of good widgets. So the number of widgets in one day, the number of good widgets, is going to be 100% minus 4%, which is 96%. So what we have to do is get 96% of the number of widgets produced in one day. And that's the number that we got in part 1. So 96% of 21,900,000 is going to be 21,024,000. So to get a percentage of something, we can divide by 100 and multiply by the percentage, so divide by 100 and multiply by 96, or we can input into our calculator 96, the percentage symbol, then swap the of for the multiplication symbol and put in our number. Okay, so the number of widgets in a 5-day week is literally just going to be our answer to the first part multiplied by 5. So 21,024,000 multiplied by 5 is going to give us 105,120,000, and we want to change that to scientific notation. So what we're going to do is move our decimal point to the left until there is a number that is greater than or equal to 1 and less than 10. So our decimal point is at the end of any whole number. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 places to the left so that the decimal point is just after the first digit. So we have 1.0512, and that's going to be times 10 to the power of 8 because I moved the decimal point 8 places to the left. So the question asked to find the number of widgets produced by the company in a day, and we got 21,900,000 widgets. And then it asked if 4% of the widgets fail the quality test, calculate the number of good widgets produced by the company in a 5-day week. Or another way of saying that is the number of widgets that pass the quality test. And we got that to be 105,120,000, which we can rewrite in scientific notation as 1.0512 times 10 to the power of 8.